Good morning, everyone. I think the whole team here is very happy to be here. We've got good content, a good demonstration as well, and you'll find some news, some things that we haven't talked about yet. So we hope you like it. Like Fred said, we will appreciate if you make it as interactive as possible. Also for me, it makes it easier for us and more interesting. I'll introduce myself quickly. I lead regional marketing for the storage business unit of Micron in Europe, which includes ecosystem development on the enterprise storage side. And I'm here this morning with my colleagues, my more technical colleagues, Mark Day, who is a field system engineer in Europe, and Andrew Braverman, who leads the global field system engineering teams around the world, basically, for Micron. Maybe you want to stand up.
Sure. So as Nick says, I'm Mark Day. I'm a field systems engineer here in Europe for Micron, mainly focusing on kind of the enterprise division, so enterprise customers, and I think that's about all I've got to say on the matter.
All right. Andrew Braverman. I lead our field systems engineering team around the world for enterprise, hyperscale, and cloud customers for all things Micron, whether it's storage or memory or anything in between.
Thank you. And the rest of the team, Valentina and Kirstine, who belong to our marketing, outbound marketing and communication organization. Right, so we have a presentation today which should last about an hour, hopefully a little bit less. There are 3 sections in it. The first one, which I'll lead, is a bit of a marketing pitch, but I hope you'll find it interesting, and it's also about the Micron vision of enterprise IT and specifically from an enterprise storage perspective. The second one will be a deep dive into our product and solution portfolio, and here I think Mark and Andrew will chime in more than in the first section. And in the third act, we'll open up on a couple of big questions and technology futures that we think are not quite here today, but will shape the evolution of our markets and industry. So, do I have a pointer? No. Okay. So with this, we'll crack on. A quick flashback on the industry and the markets that we serve as a company. I'll go very fast on this. So I think the big story here is that the memory markets, both on the DRAM and the NAND side, have exploded last year in terms of growth. And you can see the numbers on the slide. The memory markets aggregated represents almost a third of the total semiconductor market today. It's certainly the cross-section of the semiconductor market that's growing the fastest. And it's a reflection of memory finding itself, and storage, when I say memory, semiconductor storage, finding itself at the center of, at the crossroad of a few mega trends, such as the rise of the giant public cloud companies is one. Machine learning and artificial intelligence, which makes headlines in the mainstream media. Self-driving cars would be another one in a totally different market. We could mention the IoT, obviously, the Internet of Things. So a few mega trends that we hear about even on mainstream news that are really driving consumption for the technologies that Micron developed and take to market. If there is no question,
sorry,
yeah.
There is a question. Are you going to share the slides afterwards?
Yeah.
Yes.
Mm-hmm.
For everybody as well,
Yes.
so I don't ask it.
Yeah, totally. All 4 sessions.
Thank you.
Quick question, this data, is this raw data from research firms such as Gartner, or is it something that you sort of process yourself and take your...
It's a combination of both, apparently. So it's not purely analyst data, it's also based on our internal
so you take a
market analysts. Yeah, we have our own team that compiles information from analysts and make up their own views. So if we move to the next slide, this explosive growth trajectory of the memory markets is something that we have benefited from as a company. In our last fiscal year exercise, we turned over about $20 billion in revenues. And I will tell you anecdotally, I've been in Micron for 7 years. When I joined Micron in 2011, the revenue run rate was about 3x smaller than that. So the company has tripled in size over the past 7 years. In revenue, from a revenue standpoint. In terms of market value, it's actually even more than that. So this growth trajectory of the company can be partly attributed to a large acquisition we did in 2013, a company called Elpida, but it's also, again, a reflection of those mega trends from AI to autonomous cars to IoT that are really placing memory and fast storage at the center of everything. So that was a bit of a flashback on the industry and where we stand as part of it. I think we can move on. We've got a video that's going to take a few minutes where you're going to see a couple of our customers and ecosystem partners, big names, very respected companies, reflecting on the data explosion, this new data-centric economy, their workloads, and how Flash and SSD specifically help them address those new challenges. So let's listen to that. It's a few minutes, and then we'll do some commentary.
At Bloomberg, we have over 325,000 customers participating in the capital market, and our job is to help them understand kind of the flow of information. There are over 100 billion ticks of market data every day that flow through our system, and over 1.5 million news stories a day. And so how do we help them understand kind of those tools?
What is happening is the variety of data types that we have to deal with. It's not just a transactional workload, analytical workload, streaming, and especially some of the new machine learning and other applications that are emerging has unique and new different characteristics. Because you got all the other attributes, why do we want to have disks at all? I don't want to have hard disks get to Flash.
I think one of the key things that Flash has done is being able to kind of provide that consistency in the data retrieval, and so that way we know, when we're delivering information to a customer, that they'll be able to get it within an expected SLA. One of the great trends that we're seeing in the data center around Flash is the introduction of NVMe, and we really think that is going to be the next step in kind of improving the latency characteristics of Flash storage in the data centers.
Other attributes related to Flash is we look at not only from a performance standpoint, we look at the availability metrics we can do, because we not only want to do backups faster, we want to recover faster, because when you have an in-memory database with a huge footprint, recovery is very important. How do you do very fast recovery, which means you need to read a lot of the data that is backed up very fast.
We're able to take kind of this low latency, kind of high performance storage and be able to leverage techniques like machine learning and be able to kind of look at all the data as it passes through and be able to apply models to it to kind of say whether the market is relevant to our customers and be able to present that to them, and hopefully they can take action on it. We handle a whole bunch of news information, and we have over 500 news stories a second that come in, and with using Flash storage, we're now able to deliver them to our customers in under 100 milliseconds.
Right. So what we've just heard is essentially Bloomberg and SAP, two very respected companies, talk about how the data explosion of recent years and this new data-centric economy places stress on their infrastructure, and how Flash and SSDs help them solve those very vexing workload challenges created by this new world. And so those workload challenges are characterized by the 3 V's of big data. I'm sure a lot of you will have heard about the 3 V's. So the first one is volume. One of the big analysts has said that in 2025, the world will produce 10 times more information than in 2016, where there was already a lot of information being produced. So that's mind-blowing. And then the second one is velocity. It's been said that big data had become fast data. It has to be processed in real time. And we've heard in the videos, Bloomberg explain how they needed to sort through 100 billion ticks of financial information every day. Twitter produces 6 billion tweets per day. On Facebook, there are about 150,000 photos that are uploaded every minute. So it's not only massive volumes of information, it's also being processed in real time. So that's the velocity V, and the variety, most of this data explosion is actually unstructured data. So it's not your the old IT data neatly organized in rows and columns. It's photos, it's videos, it's tweets. That's what we call unstructured data, and it makes it even more challenging to manage from an infrastructure point of view. So, of course, this data explosion is driven by two things. One is what we see on the slide here, which is the fact that human population is increasingly connected to the web. Personally, I would have assumed that we were already above this 75%, but actually when you think of, areas of the world that are catching up still in terms of internet connectivity, there is still room for growth. And what we are not showing on the slide, but what is really important as well, is objects. So we talk about IoT, the Internet of Things. The premise of that is that over the next years and decades, billions and tens of billions of objects will start feeding information of their own into the cloud. So that's what's driving this data explosion. Right, so today we're going to talk mostly about the data center side of the equation, the central cloud, maybe a bit about the edge cloud as well. But let's remember that the technologies that Micron makes, DRAM-based, NAND-based, also live at the endpoint level of the cloud. So, PCs, for example, notebook PCs, you all have notebook PCs, sorry. The attach rate for SSDs in business PCs today, notebook, is 50%. So chances are you have an SSD in your notebook, and you might have a Micron SSD in your notebook without knowing it. We work with all the big PC OEMs. So that's not what we're talking about today. That's not the focus, but keep in mind that our technologies are also super relevant at the endpoint side of the cloud. And that's not only notebooks, by the way. The slide is about notebooks, but that's also cars increasingly. That's also all kinds of sensors in the Internet of Things world. And Micron is also a force at that level. But that's not the focus of today. So if we move to the next slide, looking now at the data center side of the equation, specifically from a storage perspective, we're going to talk about memory as well, because it's all part of the same kind of computing chain. But really, the pitch today is from an enterprise storage perspective. And Andrew and Mark, a bit of color around how storage and memory can work together for solving workload challenges. But from an enterprise storage perspective, these here on the slide are the big trends that we see drive consumption of SSDs and also memory in the data center. And they broadly correspond to what Gartner has called the transition from mode 1 infrastructure and applications to mode 2. So from a storage perspective, it's a move, it's a transition from legacy SAN architectures and NAS architectures to server-side storage. That's a big part of the Micron point of view of enterprise IT and enterprise storage. Server-side storage. And the key premise of moving from legacy storage architectures to server-side storage is to place data as close as possible to the compute to reduce latency, which is very important in this new data-centric economy, and to remove bottlenecks from the system. So distributed infrastructure, scale-out, shared nothing storage, HCI, which is hyper-converged infrastructure, fast-growing analytics, all have in common this concept of placing the data as close as possible to the compute cores. I don't know if you guys want to add anything on this. Otherwise, we'll move on. Right, and so this mode 2 infrastructure in the past few years has been driven very much by the cloud companies, especially the very large public cloud companies. I think we all know, we are all familiar with their names. So we've got AWS, Microsoft Azure, the Google Cloud Platform, a couple of companies, super large companies in China as well in this market. They have been leaders in driving this move from mode 1 to mode 2. They are firmly mode 2. And the public cloud market is on a trend to represent about half of the total storage market, irrespective of technologies. I'm not talking only about flash here. We'll actually see on the next slide that for flash, this they are even more ahead of the curve. But looking at all storage technologies, we anticipate that the public cloud companies, which is, this market is very concentrated on a few super large companies, will represent in a few months or a couple of years about half of the total storage market. So that's quite mind-blowing, and this trend has accelerated in recent years and is going faster than we thought a few years ago. So that said, we are not saying, and we don't think that all enterprise IT workloads and data is going to move to the public cloud. We're not saying that. I think it's been widely commented in the past couple of years that probably the operating principle was that of a hybrid cloud. Workloads and data are moving to the public cloud. It's a secular trend, but for a multitude of reasons, some workloads and some data will remain on-premise. Compliance reasons, for example, or latency could be another one. So it's a nuanced picture, and we've even seen some very large web-scale companies that had started in the public cloud. Public cloud is perfect for startups. Once they reach a certain scale, they come off the public cloud and they reverse the make or buy decision, basically, by starting to build out their own data centers. So it's a nuanced picture, but let's make no mistake, the rise of the public cloud, especially the giant ones, public cloud companies, is one of the biggest stories in IT today. And that's something that we are very much plugged into, because I think we'll see on the next slide, Kirsten, that if we look at the very biggest of those companies, they are super important to Micron at two levels. The first one is that they represent already 50% of the enterprise SSD market. So that's mind-blowing. That was not the case 2 years ago. That's accelerated. In terms of total storage, including HDDs, it's not quite yet the case, but for flash storage specifically, they are ahead of the curve. Half of the global market for enterprise SSDs. That means that we have about 20 companies, 10, 20, 30, depends how you group them, that consume as much enterprise SSDs as the next thousands of enterprises and millions of SMBs. That's the market landscape today.
So you're saying public clouds are driving the SSD market?
I could not
Public clouds are driving the SSD market?
Enterprise SSD market, very much so, yeah, absolutely. Half of the market today. And in consumption, the other reason why we are super interested in this group of companies, and we've been working with all of them very closely over the past 7 years or so, is because they drive innovation. They not only consume a lot of flash bits, they drive innovation. They are the most innovative companies in the world today.
For new technology or changes?
The way they look at the technologies we make is very exciting for us. A traditional enterprise, to simplify things a bit, looks at SSDs and RAM as something that is hidden in a server chassis, right? It's not at the center of how they think. When we speak to the hyperscalers, it's a completely different paradigm. They put memory and SSD storage at the center of how they design their systems and their infrastructure. So it's very exciting for us.
Yeah, and if you look at the operating model that they've developed, over time we start to see that operating model shift, not just in the hyperscale businesses, but in the operating model of those customers that decide to put things on-prem. And that comes to Nick's earlier point about server attach being a major driving factor in our business, even though there's certainly plenty of flash capacity and storage arrays. We find the growth markets in server attach.
Yeah, most enterprises aren't big on flash. They want all flash arrays, but they're not racing out to buy them. Yeah. They don't need them right away. They're not driven by them like public clouds that are insatiable for SSDs for power or something.
So, what I said, what you said, the enterprise SSD market driven by the public cloud companies is true. It doesn't mean that it's the only trend out there. It doesn't mean that the enterprise market, the big cloud enterprises don't exist anymore. It's not correct. We're still super interested in that group as well. And if I could draw a graph, which I cannot do, in 2018, you have still about half of the storage market that corresponds to legacy storage array architectures.
Yeah.
A portion of that is all flash, and it's the fastest growing portion of that half.
Yeah.
And then the other half is server-side storage in enterprises, so like VMware vSAN, for example,
Yep.
and the public cloud. So I don't have these graphs and this data here, but it's not black and white. But clearly, the rise of the giant public cloud companies and their consumption of enterprise storage is probably, I think it's fair to say, the biggest story in our industry today.
Can I ask? I'll ask a leading question. You
Yep.
don't have to answer it. Do you see public clouds continuing? Are the public clouds placing forward orders like for a decade with you? Are they signing up for multi-year contracts, or are they signing short-term contracts? The answer to the question is that are public clouds planning to grow indefinitely, or are they planning to cap out after a few years?
So I cannot comment on like what you just talked about from a Micron perspective. We don't see the end of their growth. It's a question. I agree with you. Are they going to keep growing at that super fast pace forever? That I cannot make that kind of prediction. It would take a crystal ball, I guess. But at least for the foreseeable future, 2018 and next year, I think they are still driving very robust growth.
I love talking to salespeople. Foreseeable future is this year and next year. That's all we can see. Anyway, sorry.
So no, it's a real question. It's a real question. It also depends on what happens in the global economy.
Yeah, no, that's fine.
So
yeah, I get it.
But Nicholas, sorry.
Go ahead.
Is the purchasing way that the hyperscale people buying your products the same as business as usual, or are you having to sell it as they use it? Are they demanding that they only pay as they consume, or hasn't that come into it?
No, it's the same. No, we don't have like new
you
business
ship
models.
It and you recognise revenue straight away.
Yeah. This is still the case.
Okay.
Yeah.
And what is your route into the customers? Is it through a manufacturer, or are you selling direct to them?
With the very largest guys, direct. Yeah. Sometimes we ship the products to ODMs, but we have obviously direct relationships at a technical level and also procurement. Yeah. We don't always ship directly to them, but procurement and technical conversations are direct. It's very interesting to. It's not it's not interesting for us purely from a procurement and the size of their the scale of their consumption. It's also the innovation factor. And I think Andrew is at the forefront of that. Yeah. We talk to those guys, they're system architects, they're infrastructure gurus, and the way they look at our technologies is super exciting. They are ahead of the curve. And again, those companies, Microsoft, AWS, and the other guys, I'm not going to say the 10 names, they are clearly today the most innovative companies in the world, not only for infrastructure, for a lot of other things like AI, machine learning. Yeah. So from a Micron perspective, what's new is that those companies depend on us for their infrastructure and their businesses on a degree that was not the case 15 years ago when the biggest companies in the world were oil companies and banks. They use Micron memory and well, not SSDs 15 years ago, but they use Micron memory, but it was not center stage. Whereas for those guys, the hyperscalers, it's very much center stage. It's very much, our technologies are very much strategic to what they do.
Absolutely, and we're working with them on lots of different levels. So if we take a 3 or a 4 or 5 year view, it's not just how the NAND components work, it's how the SSDs work, it's how the firmware works, and it's also how we integrate from a form factor perspective and from a software perspective into their architecture. So lots of interesting things happening in the form factor space now, and the hyperscales are really driving that in a lot of ways to get the most power and cooling efficiencies and densities that are appropriate for their customers. The problem is the legacy form factors don't necessarily fit those things. So the industry is moving in that direction, and we spend a lot of time working with them on collaborating on those things. And then we look at things like how are they building a storage stack, or how are they their software is addressing the storage so we can try and make connections and get rid of some of those legacy interfaces or software interfaces that are in the way. Those are things that don't happen overnight, and they take potentially years of innovation, but we'd like to get as far ahead of that process as possible so we can work together as they develop those things and we develop the product to align with them.
And that's something that we are doing a lot of right now. You know, we talk a lot about having the silicon to system advantage because we have that view into the media, into the controller, into the firmware, into the SSD. So it's that entire chain that we have that view into. So it's really a unique perspective that we have, not only on the flash side, but also on the memory side.
Mm-hmm. Does that then mean that you're getting involved in more open hardware design consortia like Open 19 and the Open Compute Project?
Absolutely. Yeah. So we work. I'm sorry. Yeah, we work with all those folks, and we work with the companies that are the innovators in that space. And then, you know, I think the most interesting aspect for me certainly is what's happening in the software side. So, you know, if we treated the SSD just as a black box that would accept a NVMe command or a SATA command and left it there, you know, it provides a lot less value than if we actually understand what's the right pattern going to look like based on the expected workloads and start to change the way we interface with the product.
So that kind of leads into the next question I was actually going to Barry asking. So where do you see the new generation of storage vendors, those who are focused on distributed storage architectures, the Cumulos, the Wega IOs, and the like of this world? Are you seeing them as being an important part of the landscape going forward, or at least a signal of the direction it's going?
Yeah, absolutely. We'll talk about it a bit later in the presentation, but we are reinforcing our ecosystem development teams from a storage business unit perspective. I'm actually part of this effort. I moved to that team a couple of months ago. And we engage in the ecosystem with the big, software companies that we all know, like, VMware, for example, or Microsoft, but also a multitude of startups innovating around Flash. You mentioned a couple of names that I know from covering Israel as a region in EMEA. So absolutely, big part of our strategy.
And another thing just to point out is we still have really close relationships with OEMs. That's not something that we're giving up. And a unique thing that we do have is that our sales team is actually going out there and talking with the enterprise end user customers. I mean, you saw Bloomberg on that video, right? And it's interesting because they can go to their preferred OEM and they can specify. They can go in there and they can say, okay, I know Micron's doing this. I know where they're going. So they can go in there and they can start specifying to have Micron in their system.
Yeah. And it all depends on the level of engineering capability that the company has built, right? Bloomberg is a company that has a lot of engineering capability in it, very much like the hyperscale companies do. But to specifically address the question about some of those startup companies in the software space, one of the areas that we see ourselves fitting is acting very much as a bridge between some of the innovations in the software side and the OEMs that distribute product to a lot of the enterprise end customers. So while the OEMs are building systems and they're focused on a systems level solution, we're focused on storage, and we'd like to help bridge that gap in a lot of ways to help, being that we're not going to ship, we don't, this box doesn't say Micron on the outside when we ship that.
We're teeing up a lot of the presentation that you're going to see shortly, but one of the key things also, that just to tee it up even further, is that it's that ecosystem approach is very workload focused, because we're not going in there and just selling our products, right? We want to go in there and understand what the customer's workloads are, and then we go in there with the right solution to sell that, and we'll go into that.
But is that feasible given the rapid change of workloads and that most infrastructure now has to become jack of all trades and be suitable for almost any workload?
Yes, it's a challenge, certainly, and it's always a balance. So as we design devices and we design firmwares, it always needs to be, well, how many things can we address with this, and how many features and functions that can we address that are specific. There are some areas where we can make things very specific and align with workloads very well, and sometimes things have to be more generic, traditional block type operations that then have other layers on top of them. But that continuum is very important. Are things very custom and very well integrated versus very generic? The answer to that question is it depends.
Yeah. So you're essentially going to provide or build a range of solutions, some of which will be very
driven by the hardware design itself, others of which will be making more, putting special software into the firmware that's still relatively fixed, and then you'll have another type of solution that's much more fluid at the software level, almost software defined within itself, how it manages platforms.
I think that's a reasonable way to look at it. I think what's also important is, while we want to get as close to the software as possible from an architectural perspective, we're also very interested in making sure that we influence or drive standards in the right direction. So we don't want to create a product that is so custom that it has to be implemented in a certain way. So working with things like some of the new features of NVMe, streams, and I/O determinism, and things that are starting to emerge in those areas, where we like to obviously we have seats on those working groups and trying to influence those standards as a way of doing a little bit of both without getting too custom, because we don't want to create something that is completely net trip.
Flipping it around and looking at some of the Intel revelations recently around Spectre and Meltdown, so some of these side channel attacks and the vulnerabilities between process and user and supervisor, what are you doing to sort of put security first and foremost amongst your products, and what are you doing around, say, encryption to separate sort of process memory and stop these types of side channel attacks?
Yeah, I mean, those certainly are CPU level things that...
They're whole system level things, but anything where you're caching or moving stuff around.
Sure. There's a number of areas where we're innovating. From a drive perspective, we have self-encrypting drives in many cases. We're innovating in other areas like a NOR device that is authenticated before you can load microcode for boot, for example. Right, so there's lots of areas where we're putting things in place, and certainly taking those things into consideration as we're building firmware. I don't know that I can go a whole lot deeper than that. But
yeah, I think it would be more worthwhile as a company, though, having a security posture and communication with you, like Intel's painfully discovering now.
Absolutely, and we do have a number of folks that are specifically thinking about that, and actually that's not something that's new for us. I mean, they've been thinking about that for many years as we build.
Guys, I'm mindful of time. I love the conversation, but we have a lot of content and we're running late. So I'm going to go a bit faster and move into the more technical section. So that's the Micron point of view of enterprise storage, very much influenced by the hyperscaler. Basically, as Kirsten said, we've coined an expression to describe this. It's our silicon to system expertise, and it's a holistic view of storage end-to-end from the application to the media, which is how the hyperscalers look at things. So that's the Micron point of view of enterprise storage and enterprise IT more broadly. Now, if we... Okay, so that's the end of section 1. Micron carries the load. I think you've got the message. We are at the center of the new data-centric economy. We are the cornerstone of the cloud, and we are super strategic to the biggest companies in the world today, which is new for us as a company, and explains the explosive growth trajectory that you've seen at the beginning of the presentation. Now we're going to move into what we call our workload optimized portfolio of solutions. The key word here is workload optimization. I tell you, a few years ago, probably 7 years ago, let's say, when we were designing SSDs and maybe memory as well, the design principle was to optimize for performance. And today, while performance is still at the center of everything we do, obviously the technologies we design are performance-focused technologies, we optimize for workloads. The design principle is workload optimization. And we're going to see what that means in the next few slides. First, we'll start and pay attention that there is a crunchy bit of news here. That's not a roadmap, that's our SSD portfolio for 2018. And you will, I think, note that we are basically pre-announcing, we're not going to give details of speeds and feeds, but we are pre-announcing a QLC-based SSD targeted at the enterprise market. So SATA interface, enterprise, QLC SSD in the second half, that we will launch in the second half of 2018. So there are a few things to say about that. The first one is that we are starting with an enterprise SATA SSD, but we will flow QLC, the QLC technology, into more swim lanes, more SSD swim lanes next year, including NVMe and client consumer drives. So we start with this, but it's not the end of the story. This product here is going to be targeted at super read-centric workloads, what we define as high read-centric workloads, such as warm workloads, write once, read many, content streaming, analytics on data lakes, and my colleagues here will give more context around that in a minute. And the other thing that we've heard from engaging with some of those hyperscale companies about QLC is that some of them are contemplating to use QLC SSDs as an additional tier between TLC SSDs and nearline HDDs. So there are, it's starting to, QLC is new, right? It's been discussed and there was a bit of hype over the past 18 months around it. It's starting to happen. And we actually have QLC wafers today that we are going to show around. So these are the wafers from which we cut the dies that we package into chips that go into SSDs. So this is QLC NAND.
So each of those dies are 64 gigabytes?
64 gigabyte per die. It's 64 layers NAND as well. We'll say a few words about that later in the presentation. So I think this is exciting. The industry has been talking about QLC for a while now. It's happening. It's starting to happen. We hope, we can never be sure, but we hope that we will be first to market with an enterprise SSD on QLC in the second half of the year. And in the last chapter of the presentation, we'll ask the question, what is the impact of this on the HDD market, right? So hold off your question until we get there. But that's one of the big questions out there.
What's the impact of QLC to the latency of reads and writes, etc.?
We're not talking about that today. This is a pre-announcement, so we'll regroup when we have more news to share later this year. Yeah. But I think broadly put, we can say that there is a trade-off in terms of write performance. The read performance for QLC at SSD level is going to be similar to TLC. For the write performance and the endurance,
yeah, they are.
So endurance and write performance are going to be less than with TLC. But that's understood, that's acknowledged, and it's going to be targeted at different workloads. So with that, let's move on because we are running a bit tight on time. We're going to go very fast on the product slides. It's not the most interesting. This is the client SSD portfolio. We are also pre-announcing a client NVMe SSD that will be launched later this year, but targeted at PCs, so we can skip on that. Next one, yeah. So that's the enterprise SSD portfolio, the products that we ship today to those system OEMs and hyperscale companies. We have an NVMe offering, the 9200. The 5200 is a product we launched a few weeks ago, and I had the pleasure to brief a couple of you on this back then. It was, at the time of launch, the first enterprise SSD using 64 layers NAND, TLC. And the QLC product that we just introduced will be leveraged off the 5200 design in terms of subsystem design. Okay, so it's not all about SSDs when we speak about our portfolio of solutions for enterprise storage, enterprise IT, optimized for workloads. We wanted also to talk a little bit more about NVDIMM-N, which is not a new technology, and I think if you followed our news, you will have heard us talk about NVDIMM-N for over the past couple of years. But the reason we are talking about it again today is that we've introduced higher densities recently at Supercomputing Denver in the fall. And also, we do see broader ecosystem enablement picking up momentum. As a matter of fact, at SC17, we announced a collaboration with Dell and VMware to to basically leverage NVDIMN in virtualized environments. So we see NVDIMN being adopted in those new Mode 2 architectures and for Mode 2 applications. That's still taking pace basically. So this also shows, by the way, so this is the latency hierarchy view, and it shows that system architects and IT pros in general today have more data storage tiers and kind of memory storage tiers than they used to have 10 years ago. 10 years ago, you only had hard drives. So you could play between 15K, 10K, and 7K. Today, you still have hard drives, although the 15K drives are kind of disappearing quickly. But you still have those. But you also have SATA SSDs, TLC, but also now QLC. You have NVMe SSDs that are higher performance, lower latency. And then you have what we call the storage class memories that basically share some of the performance attributes of RAM, but have persistency as well. So 3D crosspoint-based technologies are part of this group. NVDIMN is also a storage class memory, but optimized for performance. 3D crosspoint-based technologies are more what we would define as storage class memories optimized for cost. They try to find a sweet spot of cost per gigabyte in between RAM and NAND. The performance is not quite as high as DRAM, whereas for NVDIMN, the cost is higher than RAM, but the performance is the same as RAM, and it's persistent, which RAM is not. So that was my introduction to NVDIMN. The densities per single modules are relatively small. Today we cap out at 32 gig per module, but for the target use cases that the technology is addressing, it's very relevant. It makes a lot of sense. And maybe we can move to the next slide.
I think one other point that you can make on the slide, if you look everything from the HDD over,
yeah.
Everything from that HDD over, that's Micron. We make all of that technology that goes back to that silicon to system message that I was talking about earlier. It's a pretty big chunk of what we're trying to drive forward.
Absolutely, yeah. Everything on the left of HDD was Micron Technologies, and the idea of tiering data sets between different tiers of storage and memory technologies is a big trend. One of the things that the hyperscalers are driving. So it's very relevant. NVDIMN, so I think I said everything I had to say on this, but maybe Mark and Andrew, you want to add some?
Sure. I mean, we'll actually have a demo later actually showing some of the capabilities of NVDIMN. But in reality, it's exactly as Nick has covered here. It's a non-volatile DRAM module. So in the event of a power loss, what we'll actually do is copy the contents of the DRAM down to the onboard NAND itself. And then obviously during power up, then it does the reversal of that process and copies it back from the NAND straight up into the DRAM. So there are two modes that we can operate in with this. We can operate in a byte or a block mode. So obviously, if you're operating in a byte mode, you can have the performance benefits of operating at the speed of DRAM, but that comes with some complexities as well, because generally speaking, you would need to make modifications to the operating system or to the application layers to benefit from this kind of new memory space. Historically, obviously, we've only had volatile and non-volatile, as in volatile being DRAM, non-volatile being disk. Now we're opening up this third space that needs slight modifications to applications to take advantage of. If you operate it in the byte mode, though, obviously we can just make NVDIMM appear as a raw block device. So people could just use it as another disk layer. There's a slight performance penalty for doing so, but it's the easiest way to adopt the technology now. And people can start using it for things like write buffering, logs, transactions, anywhere where latency is key. If you needed to acknowledge a packet coming in as quickly as possible and respond, that's where NVDIMM is going to fit in.
And yeah, the other idea I said is ecosystem enablement. So today you have servers like this Dell server that supports NVDIMN. This is new for Dell. At the OS level, there is support from the big, Linux distributions, and also from Microsoft, by the way. And so, yeah, the ecosystem adoption of this technology is picking up momentum. That's why we are talking about it again at the end of at the start of 2018.
and it's also a great platform when what Mark talked about with respect to using the API to build byte mode support into either custom applications or at ISVs. This is a great platform to start as the storage class memory market starts to become broader. These are readily available components with a published public API, and as the software starts to develop there, a lot of that work can be reused as we see over the next 2 or 3 or 4 years as storage class memory becomes more prevalent across the industry.
So just going back to you talking about the multiple layers now,
yep.
the increasing amount of choice there is, do you think that will continue? Is there enough of a price break between each of those layers to make it worthwhile customers implementing and having to support each of those different layers?
Personally, I think so. That's what we are observing today. And I think it's not new. There was, one thing that I heard was that there was never enough IT budget to put all your data on the fastest tier. That was true 10 years ago before SSDs. It's still true today, and I think it's going to remain true, right? So the market today has more, offers more tricks in the bag of tricks to architect those systems, basically. You can play with many more data tiers than you could 10 years ago. It's a big trend with the hyperscalers. So I think, yes, it's going to...
I also think that potentially it's driven by the end users as well. So if we think of it that the end users are the ones driving this kind of need for lower latencies and faster responses, I'm wondering whether the companies themselves can afford not to try and keep up with it. If a company is providing a good level of service and a fast response, can another company afford not to implement equivalent standards?
And there's public cloud is 50% of the market. Public cloud will use the faster stuff. And, they're driving markets instead of the enterprise passively taking the turd that comes down the boot chute. Enterprise would sit there and take 10 years to adopt a new technology. You can't have multiple products. But with public cloud sucking up 50% of their capacity, the go-to-market just all changes. So,
there's also other limitations. It's not just about cost. So NVMe, for example, big uptick, great adoption rates. But there's still limitations in the number of PCIe lanes that systems have, although that's getting better. We're seeing in Skylake and AMD EPYC and other things in those areas where we're seeing investments. But in addition, power, right? So you look at SATA, 6 watts. Common NVMe SSDs anywhere from 12 to 25 watts. So lots of differences from power consumption perspective. Can you build a rack or a data center or hyperscale environment based on all that power? There's a lot of moving pieces. So the answer is yes. Over time, I think that we're moving up towards the left, but it's not just a matter of cost. There's a lot of other aspects that come into keeping a lot of these tiers relevant.
There's another one here too. I was talking to a customer yesterday who was pointing out that 6 NVMe SSDs will saturate a 10 gig internet network connection, right? And so we're now boosting his storage servers to 50 gigabits per second. So he can mount 40 SSDs in a chassis, a 4RU chassis, because we can now saturate that connection. And so we're now building out network. I'm literally designing a network infrastructure to run at like multiple terabits per second, so that I can get to my storage array.
Absolutely.
He's got 40 petabytes of storage, which runs it planning to run it over 6 terabits per second sustained load.
But this is kind of the history of technology, right? We're always shifting that bottleneck somewhere around a system. So the current one is
everything in IT is about caching.
If you can optimize in the software layer, we built a system in the lab that with optimized software that saturated a pair of 100 gig links with 4 SSDs, 4 NVMe drives, 200 gig links.
I can't help but think, thank goodness we've got EMC out of the way. Now we've actually got innovation in storage. Without EMC around, there's no point.
Can I quote you?
Yeah. It just strikes me, like everything used to come out of EMC, and EMC was like Cisco. It's a sales company, not a technology company. They run around selling breakfast cereals, though it's a vitamin supplement sort of thing. And now that EMC's out of the way, all of a sudden the storage industry has taken off. It really is striking to me how far it's come.
It was amazing to work with Iceland and routes to market, and then see the uptick when they managed to put it through the EMC sales channel.
Yeah,
was just incredible. You get 10 times.
But that's all breaking down now.
No, sure.
Yeah. That's the key transition.
So, so workload optimization, how do we do it concretely? What does it mean? To optimize SSDs and NVDIMMs for workloads, we need to test our products on the key mode 2 workloads that drive their consumption. So that's one level of looking at this. We have teams, specifically in Austin, in Texas, that have a lab, a data center really, where they build systems and they test our products for those workloads. And by the way, these are just examples. We also work with NoSQL databases, with Hadoop and many others like that, with the aim of optimizing our products for those workloads in terms of the development process. And this is also part of a broader go-to-market strategy where we want to make sure that the market, our customers, can fully utilize the potentialities of our technologies. And so we work with the ecosystem, with those software companies here and with server vendors, you know, the big names that we all know, to build systems that are optimized for taking advantage of SSDs and NVDIMMs for those workloads. So it's a big part of our strategy, ecosystem development, ecosystem enablement, and it's also a big part of our product development process, optimizing for those workloads.
Yeah, I think the key message here as well, and I always say this to people, but I think gone are the days where it's, if you build it, they will come. Right now it's more, we build it with them and we will help them. And I think the key messaging there is we work with the ecosystem partners and the software vendors and other people to help integrate the products to the software ecosystems take best advantage of the products. So in this instance, for instance, we're producing these reference architectures to get the best out of both the software and the hardware.
Okay. I need to accelerate a bit, so let's see what... Okay, so we've reached actually the third act of the presentation. I want to make sure we have enough time for the demonstration. So we're a bit stressed. So here in this section, we're going to talk about technology futures and ask a couple of big questions. The first one is, the first one is the impact of the growth of the SSD industry on the HDD market. So I think it's pretty clear at the start of 2018 that the 15K product category is disappearing, is in the process of disappearing very fast. If we look at the next tier down, the 10K business critical HDDs, which have become de facto mission critical, we are not at cost parity yet from a pure acquisition cost perspective, but the TCO equation is so much in our favor that we have started to have a very tangible effect on that product category from a TCO perspective. In the server-side architectures that you find at the hyperscalers or cloud enterprises, also in storage arrays, SSDs are fast replacing this 10K product category. Now, when it comes to the nearline capacity optimized HDDs, your fat HDDs that are used for cold storage and big data applications, it's a more nuanced picture. The announcement that we've done today of a QLC SSD for the enterprise is another step on that journey to challenge this product category. It's not going to happen overnight for a number of reasons, but it's the start of a trend. A number of reasons, I will give you two, or actually maybe not reasons, but I will say in 2018, the cost gap in terms of acquisition cost between a QLC SSD and a fat nearline HDD is still going to be quite significant, about, of the order of a magnitude. But the pace of cost reductions in the SSD industry is clearly happening faster than the pace of cost reductions in the HDD industry. So the cost curves are getting closer and closer over time, and it's inevitable. The thing to understand is that we actually do not need to be at cost parity with those 7K HDDs to start challenging them. Again, the TCO profile of SSDs is so much better because of the savings that you can drive with flash in terms of power consumption, in terms of the density of the systems you can build, which, you know, QLC will only amplify that trend, by the way. And the savings in terms of reliability as well. SSDs are more reliable than those capacity-optimized 7K HDDs that have, you know, even more moving parts than legacy HDDs. So if you take into account all those factors, there is a sweet spot level probably, which is a multiple in terms of dollar per gigabyte, where SSDs and QLC SSDs will start having a major effect on that market. I don't think it's for 2018. 2018 is the start of a trend in terms of, you know, challenging this product category here, but it will happen, I think, inevitably over time. And the other thing to understand is that the combined production capacity in the NAND industry is not enough today to replace HDDs, including those ones. This product category here represents the biggest share of bits in the industry, the HDD industry. In terms of what SSDs represent of the total storage bits shipped in a year, we are somewhere between 10 and 20% this year. In value, much more. The SSD market is probably as big as the HDD market today in value. But in bits, it's between 10 and 20. So we cannot replace all the nearline HDD drives just now. But as the combined production capacity of the industry increases, and as the cost curves get closer, it's a long-term trend, but I think it's inevitable. The other big thing, and then we'll move to the demonstration. Actually, I'm going to check time, but I think we're good. Before the other big thing, actually, we have this slide, which is about the NAND technology. So we've talked at SSD level, but I think it's obvious, but of course, better SSDs come from better NAND. And I think as a company, we've made very significant progresses over the past 3 years or so to achieve best-in-class competitiveness in NAND at a density level, which correlates with cost and cost competitiveness, but also performance level. So we've called out here on the slide a few dimensions where we win, so throughput, power efficiency, endurance. At the die level, you know, I think we passed around a wafer with you know, dies on it. So at the die level, our technology is best in class. Is the word I will use. I don't want to, you know, do a comparison and a ranking, but best in class certainly in terms of performance, features, and density. And density, again, is a measure of cost in our industry. And you can see that on the slide here. We've got, we believe, with the die we use in the 5200, the cloud SSD we announced a few weeks ago, the densest die on the market. So that's important. And the architecture that we use to achieve that is very unique. It's actually shared with Intel today, but it's very different to what our big competitors, the other big competitors, do. So we use the floating gate architecture at the cell level, which the rest of the industry does not. They've used another technique, charge trap. And we've also been able to place the logic circuitry underneath the NAND array. So in a NAND, on a NAND die, you have some logic circuitry. It's not only cells that keep data, you have some logic circuitry. Normally, typically, it's at the periphery of the NAND array. Our design puts it underneath, which helps us drive the bit density.
So is it a single die? So you just stack it 3D to logic under the, right? So it's not two dies?
Yeah, it's a single die. It's a single die, and you have the logic is underneath. Then you have the NAND array, which is, to your point, 3-dimensional, 64 layers.
So you managed to combine CMOS logic and the 3D floating gate structure.
Correct.
Okay, in a
single die. Single process.
And this is correct as, second question, is it in high volume production? So
oh, absolutely. So this die here, this very die that we are commenting about here is what we use in the 5200, which is the last cloud SSD the latest cloud SSD we announced 3 weeks ago, which is shipping. It's shipping. And
but this is a very much ramping technology, so it's not like it's been
It's ramping, but I think by the end of the year it will represent a very, very significant share of our total production. I don't want to say numbers because I haven't prepared that, but I think it's out there. We've made some comments on that, our executives.
But note that this architecture was used for our previous generation, the 32-layer. So the 5100 class drive and the 1100 class drive that Nick mentioned earlier, while it's not as dense as this because it has half the number of layers in it, still uses the same architecture. So this has been shipping for quite some time.
Okay. So the logic beneath the plan is not
correct.
Really loose,
No.
the higher number of
That's right.
You're right. Yeah, good point here. Yeah, the CMOS under the array, what we call CUA, is something we introduced with our first generation of 3D NAND. And this is the second.
Changes to the process, like the geometries has changed, improved, like shrinks in geometries, or is this just the layering of?
We don't talk about the geometries anymore, and we're not.
I noticed the industry stopped talking.
Yeah, the industry stopped talking about it because it's not a good measure anymore of density, basically bit density. So it's kind of irrelevant.
Okay.
It was only really relevant, or mostly relevant, on the old days of 2D NAND, right? So when it was all planar, then you really cared. The denser you could make it, or the lithography scales, when you got it smaller, meant more bits. Now we're going vertical. So although it has some relevance to the amount you can get in, it's more about how high can you stack and what the density is of that.
Okay.
Okay, so last but not least, we've got, I think, in my view, a very interesting section for just a few minutes. This is a nice slide, but we don't have time to talk about the 15 trends here. We can come back on that after maybe the demo if we still have time. I wanted to focus on one in particular, which is this one, flash optimization.
Can I just check what's the scale you've got there? I presume it's years, but you know.
Yeah, it's a bit weird, this slide. It's not mine. You've got years here, and then there is no y-axis. You've got those two axes here, SSD development and media changes, and they've mapped the trends along those two axes here. So it's a marketing slide. But the point here is that I want to focus on this one, flash optimizing software at the server level. If we move to the next slide, what if the storage stack was optimized for SSDs? So the background here is that the storage stack in between an application and an SSD has been developed over the decades with HDDs as the design principle, if you like. So it's not optimized for SSDs. And in Micron, we've been doing some work over the past few years on trying to understand how the storage stack worked with flash. And we found that it was vastly inefficient, basically. We found that it was vastly inefficient. I'm going to show you some data that will help illustrate it. I think it's quite interesting. And we've designed in our labs a storage stack optimized for SSDs. So a Micron storage stack, if you like, optimized for SSDs. And when we replace the traditional storage stack by this Micron storage stack, we observed tremendous improvements at many different levels. So we'll see, we've got data slides coming, but the first level is probably this one. We are able to reduce write amplification above the drive in the storage stack, and that translates directly into higher longevity for the SSDs. We write less at the SSD level, if you like. The other levels are basically latency, performance at the application level, which is really what matters, and even power consumption, which is a little bit less intuitive, but I'll explain. So if we move to the next slide, I think there is an animation. So, and that I will tell you, I started, learning about this work we were doing probably 6 months ago, and I struggled with understanding what we were doing because there was something that was new to me, even though I've been in this industry for a while, which is there is write amplification happening in the I/O path above an SSD. I was familiar, like some of you, I'm sure, about write amplification inside an SSD because of garbage collection, but there is also a high level of write amplification happening in the storage stack above the drive. And so when we replace the legacy storage stack designed with HDDs in mind by one optimized for SSDs, we are able to yield improvements of an order of magnitude in terms of write amplification without doing anything inside the SSD. This is based on There is no magic in the SSDs. The magic is above. And so an order of magnitude reduction in write amp, which directly translates into increased longevity for the SSD. We cannot really say we increase the endurance because it's still the same SSD, but we write less to it. The application still writes the same, but we write less to the drive, and so the drive will last longer. And maybe that's a thought to consider in relation to the QLC SSD announcement we've just done as well. So the other level is application performance. So again, without doing anything special at the SSD level and anything special at the application level, by rewiring the storage stack, we are able to drive application performance up by an order of magnitude. And that really is a story of the SSD performance that is wasted in the legacy storage stack. SSDs have super high performance in terms of IOPS and latency, but a lot of that, this is another way to look at it, is wasted in the storage stack. So if we optimize the storage stack for SSDs, you can fully utilize you can unleash the potential of SSDs really. So that's
some more technical details, like just ideas like its queue depth, its the block sizes, it's how do you
so I might disappoint a bit, but this is all pre-release NDA stuff, and so we are teasing the work we've been doing, but we're not going to give details of implementation today.
Okay.
I hope later we can regroup and, later in the year or later to talk more about that, but this is more a high-level glimpse into the work we've been doing in the lab, and by the way, also with customers. So we are working with a few customers on this around the world to test with real-life workloads.
It goes to your point where you were saying, innovation is finally happening in storage again. I mean, this is proof into different ways that we can look at storage, and that's something that we're doing in our labs at Micron.
Yeah. I wouldn't get too carried away about it. There's not too much innovation happening in storage. This is storage.
It is storage, sure, but you can innovate within it.
Yeah.
Will you be contributing this to Linux? Contributing back to the community.
So is it mainline kernel is going to go upstream?
No details about implementation or the strategy to take this to market today. Just a glimpse into the technology. It's one of the most exciting things we've been doing. I'll just show you 2 more slides. Latency as well, a 95% reduction in average and tail latency. Tail latency is one of the hard problems with SSDs for certain workloads. So not only are we able to reduce the average latency by almost 30 times here, but also the tail latency, which is the latency outliers. You're going to have, if you do 1 billion IOs to the drive, you're going to have, most of them are around the average, but you're going to have some of them that are way faster than the average, but some of them will be sometimes as slow as HDDs, right? So with this technology, we can get rid of the latency, the I/O outliers in terms of latency. So that's super important for the Mode 2 workloads we talked about and this new, data-centric web-scale economy, super important. And also at the drive, at the power consumption level, so this one was a bit less intuitive for me as well, but I can explain you. What happens is that the operations that consume the most power on NAND, on an SSD, are the write operations. Writing bits on NAND is what consumes power. So by reducing write amplification in the stack above the drive, it has a direct effect on power consumption at the drive level, and it's even compounded at the system level. I cannot explain the details, but yeah.
What system level are you talking about? The storage system level?
Yeah, server, storage.
85% at the gross system level.
Server, storage system.
It reduces per IO.
Yeah, but still, if you've got 85% at the drive level, you can't have 85% at the system level because there are other components that this just doesn't affect.
Sure, and that's probably a very storage-centric system.
Right.
Okay, I get the point. But I think
it could be misleading.
No, I understand. What I understood, I cannot go into details, but you at system level, at system level, there might be even more power savings because the CPUs will be fed better, also because of the latency reductions and all that. So anyway, broadly put, major improvements at many different levels, and we think this is very exciting, very important technology that will have benefits not only at the infrastructure level but business level as well. It's
only if the ecosystem actually adopts it as well, which is getting back to Brian's earlier
so
question about.
so the approach here that's important. The remark you made is very relevant. There are other approaches out there trying to solve the same kind of problem, which is basically to better utilize NAND, right, for those new workloads. The approach that we are driving is really to change the storage stack, but to keep the applications as they are and to keep the drives as they are. And we think that's the right approach to drive broader.
Which is fine as long as the rest stays the same as well, or that if this is embedded in the operating system, that is also changed correspondingly, because people want supported everything, not just the supporting storage stack.
Yep.
Is this being driven by the demand of hyperscale cloud vendors, where they look at the issues they're having with retrofitting Gen 1 and Gen 2 data centers?
I think you're right. The hyperscalers are at the bleeding edge of optimizing everything, right? So they want to optimize everything they control, and certainly when we look at SSDs, those guys, we need to understand they control the I/O path from end to end, basically. Some of them build their own SSDs, by the way. So they control everything from the storage to the application. So they are thinking about things like that. What we are doing is part of a body of work that is relatively broad. There are different approaches out there. But again, I think the key point here is that we are thinking about adoption by the market, right? And we want to make it simple.
Yeah. You change the software drivers in Linux and you'll get this for benefit. You can't change the database apps. You can't change, all you can do is change the Linux storage drivers, and that's where it has to be. It's not like you can influence anything else.
So you're probably not wrong, but we're not going to talk about implementation. Now, there are other approaches that require specific SSDs and also rewriting the applications. That's not what we are doing here. We're changing the bit in the middle. And that was it. So now I'm going to hand over to Mark and Andrew for the demonstration, which is around NVDIMN used in block mode and NVM. We've got 15 minutes.
Yep, absolutely. Okay, guys. So as I've only got 15 minutes, we'll keep it quick and brief. Really what we're showing here today is I try to just do a basic demo to show you the differences in both performance and throughput into IOPS latencies, and the differences between non-volatile DIMMs, so NVDIMM modules, and our latest generation NVMe devices. Okay, so that's what I'm trying to show here today, all right? What it's going to be using is one of the latest generations of the Dell, so this is a Dell 14G server, using NVMe devices and also using NVDIMM, all rolled into one box that's commercially available now. I've actually used a software partner here through Enmotus, and Enmotus do a variety of software, but their main purpose in the ecosystem is to provide tiering software. So they're able to actually produce systems that would use NVDIMM in collaboration with NVMe drives to provide a tiered hierarchy, so that they will pin data through virtualization. They will pin the data at either the fastest tier or the slowest tier, depending on what's hot and what's cold within that access. Does that make sense? Have I explained it very well? So in Motus' job, they virtualize the SSDs, create a single namespace, and then they can tier the data between what's hot and what's cold. Okay? So you're always going to be getting the fastest performance, the fastest data out of the fastest segment. So that's that. In this particular demo, what I've used is their software in the most basic of manner. And what I've got is 2 NVMe devices, and I've got 2 NVDIMMs in here. That's it, just 2 of the 16 gig DIMMs and 2 of the 1.5 or 1.6 terabyte NVMe devices. And I'm using their software just to aggregate the devices together into a single namespace. So both NVMe devices, instead of being 1.6 terabytes, are just going to be 3 or 2.8-ish terabytes, okay? And again, with the NVDIMMs, instead of being an individual device of 16 gig, then it's going to aggregate them together for me and produce me a roughly 30 gig partition in which I can use. The latencies from what you'll see, the latencies are slightly higher on the NVDIMM because I'm using it as a file system rather than a byte mode. So it's actually going to be appearing as a file system for me. Okay. And I say all that just while it's booting up. So what we can actually see on screen as well, just to point out, is I've got PMEM, which are NVMe devices, and we've NVDIMM devices, sorry, and then you have the NVMe devices there separately. Currently, if you look in this view, they're all separate. They've not been aggregated together. And then what I'll do, just to make for this speed, just run a little script just to do all the hard work for me to actually aggregate the devices together and create new namespaces. So what this does is create new block devices for me to use. It will create me an EBA and an EBB. So it just appears as raw block device. You could do anything with them at that point. So as we can see now, extra devices have appeared, EBA and EBB. One is 28 gig in size. The other one is 2.9 terabytes in size. So just like I spoke about at the beginning, aggregating the devices together to produce a large namespace for me to play with. Pure and simple. Okay. Okay. So what the dashboard here is going to actually show us is that I could select any of the workloads we want to do, but to really emphasize the point of the latency and the bandwidth and throughput differences, what I'll do is just put a standard job, benchmark job running on the system, and this one will do a random 4K read, and it's going to be showing the differences of the data hitting the NVDIMM versus going to an NVMe device. So what you'll see is a difference in IOPS, a difference in latency, and a difference in throughput. Give it a moment to start up. On the left here, as we can see, we've got the local latency, average latency that we're seeing of the NVDIMMs versus the NVMe devices. Going over to the right there, then you'll see the IOPS. So you're seeing an NVMe device on the bottom, and on the top you've got the NVDIMMs. So in this particular example here, as I'm doing random 4K reads on the devices, the NVDIMMs in their current configuration can do approximately, we're seeing anywhere between 1.7 to 2 million IOPS, okay, somewhere in that kind of range. With the NVMe devices, then we're seeing approximately 800,000 IOPS, 800 to 900,000 IOPS coming through. And again, the kind of the bandwidths and the latency figures speak for themselves. So if we look at the bandwidth, NVDIMM is capable of delivering 4.7 gigabytes per second in this demo, whereas the NVMe devices are actually producing 2.2 gigabytes per second in random reads coming through it. And the whole reason for showing this is just, again, going back to the software ecosystems and the differences between the hardwares of where there is innovation in the marketplace, where software is key and important to doing it, and where we're starting to see our customers and large organizations starting to use NVDIMM and also in combination with software partners to produce these tiered hierarchies or to provide, to choose the right product for the lowest latency when required. Is there any questions on this as well?
I think your point earlier about ease of access is the whole idea that NVDIMM has some really interesting potential when you start looking at, you know, byte mode and writing to the API and all that. But there's only a few places or a few customers that have the capability of doing that. What we're showing here is that it's not 100% when you take the easy way, but you still get a lot of benefit by taking the easy way.
Yeah, absolutely.
And what's not shown here, but obvious, is the cost per gigabyte of the two technologies is very different, right? Because when you see it like that, you might think, why use NVMe flash, right? The other one is so much better. Yes, but it's a lot more expensive as well. So the idea is really to tier your data sets between the two.
Yeah, that was going to my question.
Yeah.
So what can you do for customers to, I mean, beyond the hardware scale, as I imagine, because they do it for themselves, to enable tiering between the memory and the storage side.
So in Motus as the software partner and various other people on the out there
Because
can do
Intel
this.
is the driver. I mean, can you tap into that, or is it specific to their Optane drives? Because they develop software for that. So basically, the system views the Optane drive as memory
Right.
through PCIe.
So this particular demo and this software is capable of doing similar things to
Okay,
that.
so you can do that.
So what it would do is it could tier together the NVDIMMs with the NVMe devices.
Okay, so you can already do that.
Okay, and so you could do that in the software level. So it would appear as a single namespace for them to use, and it would pin the data, whether it's hot or cold or active or not active, in the true kind of tiering approach. So that instead of having to buy all NVDIMM for all of your data, you can now just tier what's hot and what's not between the NVDIMM and the NVMe devices. And that's done in real time within the software. The software can actually determine what is current and active and hot and place it in the NVDIMM. And then anything that's not currently being accessed will be pushed down to the NVMe devices and then read up again when required. So yes, it is a true tiering model.
And the software is agnostic. So in this case, we have NVDIMM and NVMe. We can build this tiering with SATA as well, and then QLC SATA beyond that, and even disk.
And it's not only in Motus. There are other companies that are working on similar ideas, and even VMware. You know, I mentioned VMware. We announced a collaboration. Are looking at utilizing NVDIMM-N for vSphere and maybe vSAN later down the line. So not only startups, also big players.
Are these essentially just so you have two sort of persistent memory players, or is there something else that you're working on? So NVDIMM and I guess 3DX Point is also kind of your product, right?
Yep.
So is there anything else? Because there's a lot of sort of like persistent memory in development.
So
racetrack nanowires, persistent magnetic.
Yeah, there are plenty of technologies that are
chosen
at
like
lab
because
stage.
NVDIMM is essentially it's just taking two old technologies and smashing them together. So are you working on something more interesting than that?
So no, it's a good framing of things. 3D Crosspoint, you mentioned it. We're not talking about it today, but it's still a focus for the company. In fact, our CEO, when we announced our results, fiscal quarter 1 in December, made some comments about that. So historically, the company has been focused on productizing the wafers, if you like, and ramping production in our fab in Lehigh. That's been the focus of our efforts. However, we've started resourcing a product development team. So we're looking at, having a roadmap for devices that will use 3D Crosspoint. We haven't revealed it yet, right? So we're still at that level. But that's still a focus. And then there are other storage class memory technologies that are at lab stage. And I think as one of the top 5 players in the world, we are looking at all of them, right? At any time.
Yeah, and Sanjay has also mentioned some of the investments we're making in R&D. There's nothing that we're ready to share yet, but certainly the company has thrived on innovation over the years, and it continues to be a focus. So there's a lot of investment in technology development and the people that invent these things. So
it would be fair to say that you haven't chosen your next bet in terms of persistent memory.
I think it's fair to say there's a lot of work being done in that space. I realize that's kind of obtuse, but
NVDIMM, even though to use your words, it's just smashing two existing technologies together, is the most mature storage-less technology today. That's also why we're still talking about it. We realize it's not new, but it's gaining broader adoption in the ecosystem. I mean, the VMware and Dell story is interesting. It's two big companies coming together with us to find new ways to utilize the technology. Creating virtual NVDIMM-N in virtualized systems. So it's an interesting technology. It's not as new as the other things you mentioned, but it's interesting.
I think to your point, though, I think it's key to remember that Micron is an engineering company. It's where its background's from, and it's what we still are today. So opposed to other companies that have been mentioned in this room today, Micron is still an engineering-based company, and we are looking at all technologies.
Yeah. So we have 3 minutes left, but I think we're on our side. We've done our job. So if you have questions, we are happy to take them.
Yeah, I mean, being slightly devil's advocate, I mean, the price of storage per unit, whatever, how you want to measure it, it's still coming down, right? So, I mean, how far can you go here? How much do you invest in R&D? Because people expect all these things, they're given now. People mentioned Intel before about security problems there and all the rest of it. It makes you wonder why they oversaw it. Maybe they just thought it wasn't worth bothering about. I don't know. People expect all these things now. I'm just wondering what the future is for your company and the industry, you know, per se. Seeing that the hyperscalers are dictating things now.
Well, dictating is not the right word. We are very much collaborating with them. And if you remember the financial performance slide that we showed, we have a lot of how do you say, tailwind with us at the moment in the industry. So memory and fast storage technologies have always been important, but today, and I think in the years to come, they are even more important. So we are optimistic. As a company, we see opportunities rising that we could not see a few years back. The world has changed in our direction, basically. So I don't know if that answers the question, but you know, our technologies are more valued from a consumer or an enterprise perspective than they were a few years back. It's become more strategic.
And I think if you look at how the workloads are changing, especially with, you know, with machine learning and AI, all of those types of workloads are, our technology is absolutely critical to making sure that those, you know, real-time analytic type workloads are running in the industry. And so that's something that we're working on, and you'll start to hear more from Micron areas that we're exploring to enabling that.
Yeah. Okay. So thank you for your time.
Thank you.
Thank you. Thanks.
Thank you.